Welcome to part 6 of our series on building a Zelda-like game in Phaser 3. Now that we have input handling in place, it's time to get our player moving. In this video, we'll implement movement logic and make sure our character can navigate the world. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Let's jump in and start moving. Next, for our player, we'll start moving our player to actually move around our scene. To do this, in our player class, in our update method, when we're checking for our controls component, if one of our input keys is down, we'll want to update our physics body's velocity in order to move our game object around our scene. To start making this change, let's add a new method to our class. We'll call this update velocity. So we'll do private update velocity. Now for this method, we'll want to be able to support updating both our x and y velocity. So we're going to add an argument called isX. This will be a boolean, and when it's set to true, we'll update our x velocity. If it's set to false, we'll update our y velocity. We'll also want to receive the velocity we want to set it to, and so we'll add in value, and this will just be a number. And for our method, we won't return anything, so we'll add in void. And so we'll do if isX is set to true, then we'll want to update this, our body, then our velocity property, and our x value, we want to set equal to our value. We'll go ahead and return, and if isX is false, then we want to update our y value. So we'll copy this, we'll paste it, let's add that in, and we'll save. Alright, so we save our code. We'll see we have an issue over in our browser and with our IntelliSense. What's happening is when we reference this.body, the type we get back from Phaser is on our game object, it's either going to be an arcade body, a static body, or null. Because our property could reference null, that means we'll have an issue if we try to call velocity on that object. And so to fix this, we're going to add a utility function that's going to ensure that our body on our game object is actually an arcade physics body. To do this, we're going to jump over to our utils file in our common folder. We're going to make a new function, and we're going to call this isArcadePhysicsBody. Let's do export function isArcadePhysicsBody. So now for our function, we'll have one argument. It's going to be body. And now for our types, this is going to be our Phaser Physics Arcade body, our Phaser Physics Arcade static body, or null, and we want to return our body, and we want to set our type is our Phaser Physics Arcade body. So now in our function, we're going to make sure that our body is not undefined, or if it's null, we want to return false from this. So we'll do if body is undefined or body is null, we'll return false. Otherwise, we're going to return body instance of Phaser Physics Arcade body. So now if we jump back over to our player class, let's add in that type guard. So we'll do if not is arcade physics body, and we'll pass in this dot body. Then we'll go ahead and return. And now we should be able to remove our optional chain here. So once we save, our game should refresh and we should see our player again. All right, real quick, back in our utils file, we're going to add in one more type for our type guard here that we'll need later. So besides our Phaser Physics Arcade static body, we're also going to add in our matter.js body type. So by default, when we reference this body on some of our game objects, because Phaser supports matter, this type is also returned on some of those references. Currently on our player, because we're typing to an arcade physics sprite, we don't see that return when we reference this body. And so we're just going to add this type here for when we have to support other body types. So now to use our new method, let's go into our update method, and after we update our animations, we'll call our new method. So we'll do this, we'll do update velocity. So when the up or down key is pressed, we're going to pass false for isX. And now for our value, when we press the up key, we want to do -1. Since we're moving up in our scene, our y value will be decreasing. We'll copy that. Let's come down here, and now we provide a +1 for our y when we're going down. So now for our x values, we'll paste that in. But now we want to set this to be true, and so when we go left, it'll be -1, and when we go right, it'll be +1. All right, so now if we save, we come back to our scene, we try moving. Oh, we have an error. Let's copy our import statement, come back to utils. Since we're referencing Phaser, we need to make sure our import is present on that file. All right, so if we refresh, now if we try moving our player, we'll see they start moving around our scene very slowly, and if we stop pressing our arrow keys, they keep moving. So we'll want to add in another safeguard where if none of our inputs provided, we want to reset our velocity. So we'll do else, let's copy this here, we'll paste it, and we're just going to do 0. We'll do the same thing down here, but now we just want to set true for x. We'll save. So now if we try moving our player, they move, and if we let go of our keyboard keys, they stop moving. So now to address the issue with our speed, we just need to update our velocity to be multiplied by some value. Just for testing, we're going to multiply this value here by 80, and that way we can see if our player is actually moving around. All right, so we save. Now if we press our arrow keys, our player will be able to move around our scene. So one thing we'll want to fix is our animations. So currently we're doing our idle animation as our player's moving around, and instead we'd want to do our walking animations. So come up to our code. Let's change this from idle up. We'll do walk up, and then we'll do the same thing with the rest of these. Now if we save, our player should be able to move around our scene, and it looks much better. So one thing we'll need to fix is if we're holding two of our keys together, like down and left and down and right, we'll see our player's animation stops playing because they're trying to play two animations at the same time. Another thing we'll have to address is our player's speed. Currently when they go diagonally, they're moving much faster versus if they just go up, down, or left or right. To fix the issue with our animations, let's go into our code, and we're going to check to see if our up or down key is being pressed, and if so, we won't play our animation for when we're walking on the side. To add that check, let's make a new variable, do const, we'll do is moving vertically. We're going to set equal to our controls, and we'll do is down, down, or our controls is up, down. So now we only want to play our animations if that's false. So we'll do if not is moving vertically. Oh, let's update our name here. So vertically. Now we'll move this check inside our if statement. So let's go ahead and move that code above our is moving vertically. And now we'll do the same check down here. And let's move this code above that. And we'll clean that up. Let's save. So now back in our scene, if we try pressing our two keys, we'll see our animation continues to play smoothly. And we only show our up or down when we're pressing the two keys. Another thing we'll want to fix is once we let go of our input, we need to go back to our idle animation. So below our code, we'll add a check to see if our input's not being pressed. And so we'll do if not, our controls is down, down, and we'll check each of our values. So we'll do and, I'm going to copy this, and we'll check our other keys. So we'll do is up, down, is left, down, and we'll do is right, down. Then we'll play our idle animation. So let's copy this, and we'll just do our idle down, and we'll worry about our direction for the time being. So now after that, after we move our player, if we let go of our keys, we go back to our idle animation. Nice. So to address our issue with where our player moves faster when they're going diagonally versus when they go up or down, we need to normalize our velocity for our player. And so what that means is currently in our game, when our player is moving up or down, we're upping our velocity by 1. And so if we just make this very simple, let's say our player is moving 1 pixel per second. What that means is if we go up, within 1 second, we'd move 1 pixel. If we go left or right, we'd move over 1 pixel. Now in our game, when this happens, we're updating our player's position by that 1 pixel. So if we go up, we increment by 1. If we go right, we increment by 1. However, when we move both in the same direction, what's really happening is we're moving our player by about 1.4 pixels. To figure this out, we can use the Pythagorean theorem. And with this theorem, we can figure out the sides of one of our triangles based on the distances of our other two sides. And so to figure this out, we would just take our sides. So we have A, so it should be 1, B would be 1. So if we square those, we have 1 plus 1. And now we take the square root of that, so that's about 1.4. And so to make our player move the same speed when we're going diagonally, we really need to have our player go to this position here where we have our blue line instead of coming all the way up here to our 1.4. And so to fix our issue with our player's speed, we really want our player to stop moving at this blue line here. This would be about 1 pixel between these 2 points here. So now to fix that, let's add a new method to our class, and we'll just call this Normalize Velocity. For our method, we won't return anything. Now to normalize our velocity, we can just reference our body. And so we're just going to copy this here for our type guard. And now we'll do this, we'll do our body, we'll do our velocity, we'll do normalize. And after we call normalize, now we just need to multiply it by our speed value that we were doing up here. And so we can call scale, and we will do our 80. So since we're normalizing then scaling here, we don't actually need to multiply our velocity here by our speed. We only have to do it in one location. And so now to call our new method, we'll come up to our update method, and let's call normalize velocity. Let's save. All right, so now back in our game, if we move our player around, we'll see they're still able to move, but if we go diagonally, we'll see that they're a little bit slower. And so now what Normalize does, if we look at our diagram, this is going to enforce that no matter which velocity we're updating, our player is going to move the same distance. To see an example of this, I'm just going to do console.log. We're going to log out our body velocity. And let's get rid of our Normalize. If we come back to our game, if we look under developer console, we'll see when we're not moving, it's set to 0. And now if we are moving, our X and Y are both 80 or negative 80, depending on our inputs. If we add back in our Normalize, we'll see if we go left or right, we have our positive and negative 80, but the moment we go diagonally, we'll see now we have a much smaller value. We have that 56 value, and that's what's making sure our player only moves the amount of distance that we need to have them move. All right, so let's come back to our code and we'll remove our console log. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching and I'll see you in the next one.